Shashank sir is shortly joining us. Meantime, I request Shri Tejas Parmar, MD sir, MGVCL, to please start the session, sir. Thank you, sir. Over to you, sir.
Good afternoon. I am Tejas. I am MD of Madhya Gujarat વીજ Company Limited, which is one of the distribution companies of Gujarat, which is catering to central part of Gujarat. So basically, as far as smart metering is concerned, we have issued award to IntelliSmart in August 2023. Earlier, it took some time to take off because as the earlier session also, we have talked much about the interoperability and all those things. So initially, it took around 5 to 6 months for us to install the first meter after awarding of the contract. It took time because our utility uses different billing systems, and AMISPs coming up with their own MDM and HES. So we have to integrate all those things and the logics of prepaid metering that is issued by Power Ministry. We had to modify our billing system in that aspect. So it took for us some time. We installed first meter in February 2024. Initially, we went as per planning. First 25,000 meters were installed by May, but there were some issues because we started prepaid mode only. We started in prepaid mode, and there were some issues of disconnection, the resistance of people, and after that we had to stop, and then we had to move to the postpaid. So now we are again picking up. We have installed around 1.5 lakh smart meters in my DISCOM. Overall in Gujarat, we have already touched above 5 lakh smart consumer meters. So the main challenge that we faced is integration with our IT system, and it is still a challenge. Every day on everyday basis we are getting some issues like the meters not converted into bidirectional mode, the bill issued, higher bill issued, the negative reading of the meter causing the bills going up to lakhs of rupees, and it is coming on the screen of the consumer's app. So these things are still there. We are still trying to resolve those issues, and one or two such incidents create havoc in the mind of people, and that is what exactly happened in just last year. So my main take is we have technology, and but technology should be enabler, not the hindrance. Here in this case, what we are facing is the technology is being hindrance to move ahead. As far as meters technology is concerned, there is no issue. Meter is working fine. There may be some issues here and there, but that happens in every other machine. So as far as meter is concerned, there is no issue. But the integration of the backend system with utilities system, because not every utility have that kind of maybe a system, because major focus of utilities was to supply power till now, and even now also our main focus is to supply 24/7 quality, affordable, reliable power to the consumer. Billing is one part of it, from which we get our revenue. So most of the utilities have expertise in the maintaining the electrical systems, and they have the lot of electrical engineers who are working as chief engineers and all. But the IT part in most of the utilities, I don't know about other utilities in India, but at least in my state, IT part was not that much focused on till date, and that is why the IT people, the capacity of IT people was not that much to get the to get used to this much amount of data and to integrate it with the newer technologies. So I think before going into the any new technology, we have to consider the readiness of the system, the readiness of the vendors, readiness of the consumers, and all those things. And then I think we have to move ahead. So that is my take about this. Thank you.
Actually, I had a request from Mr. Chandra Goel that he need to catch a flight, so I request him to please come up and share his thoughts.
Okay, till the slides come up, very good afternoon to everyone. I am Chandar Goyal. I am a principal engineer in Texas Instruments, India. I have experience of working with a lot of smart grid solution providers in India. I have spent almost 18 years working with some of the AMISPs, the meter manufacturers, in terms of helping them providing silicon solutions, right? So I have made this small presentation, just 3 slides. I am just broadly going to cover 3 areas: architecture, reliability, and security. So 1 slide each, very small presentation. And I have made this presentation from a semiconductor solution provider's perspective, right? So we don't know much about grid. We are kind of outsiders. We just work in the background. We work with the meter manufacturers, and so most of the data that I'm going to show, or the presentation that I'm going to show, is based upon what we have learned by discussing with all the solution providers, right? So please excuse me if I say something wrong which does not make sense. So in terms of architecture, I think it is now broadly accepted that there are 2 primary technologies that are successful in terms of AMI. We have the cellular technology, and then we have sub-gigahertz RF mesh technology, right? The cellular technology is good when it comes to sparse networks, right, where there are meters which are located far away from each other, where the small networks, the mesh networks, cannot be formed, right? So there are some advantages, like there is no separate gateway required, right? So each cellular module can directly talk to the tower. There is a higher range, the scalability is really high, and the latency is also not a big issue in terms of cellular networks. The big drawback there is it's high on power, right? So because of that, it cannot be applied to dense establishments, like if you have an apartment complex which has 2,000 meters, so it doesn't make sense to have 2,000 cellular modems there, which will unnecessarily take a lot of cellular bandwidth, right? So that's why the congestion in dense networks is one of the key drawbacks in terms of cellular networks. Now, when it comes to dense networks, apartment complexes, dense city environment, sub-gigahertz RF mesh is something which is a better solution. Because one thing is, it is cost optimized. The semiconductor cost is very less in this case. The power consumption is very less. You can have a mesh networking which can self-heal. So if there is a problem, if there is a power off or power loss, it can automatically recreate the network, right? And then it is also free from interferences like other you can say cellular networks or something, because of the frequency hopping characteristics. There are some drawbacks here also. As I said, if the network is really sparse, right, so it is very difficult to create a mesh network. For example, if the houses are like 100 meters apart or maybe more than that, right, in that case building a mesh network becomes a problem, right? So these are the 2 primary technologies that we have seen being used in India, right? There are other, I think in the morning there was a talk about PLC. So from TI we have experimented PLC, power line communication, in India. We have tried to implement the G3 and the prime standards, which are very rugged standards in PLC, which are proven in the world, in especially in Spain, France, Italy, all those countries. But what my experience was I have spent a lot of time in the field testing that it did not work in India. So this story is like 7-8 years back. I don't know if we have better power conditions now, but 7-8 years back, I have spent a lot of time proving the PLC technology, but unfortunately it didn't work. So primarily, we are talking about two technologies only, cellular and the sub-gigahertz RF mesh. Now, as I said, I am an outsider, so I don't know much about how the grid works, right? But whenever we go back to our R&D teams, the software development teams, the teams who work or develop stacks, right, or standards, we show them the SLAs, the SLAs which have come in the grid community, and I hope that these SLAs are done due diligently. But as an outsider, I do not understand many of the aspects, many of the points that have been put, like receiving an alert, or you can say a connect, disconnect, right? Or a power outage, connect within 3 minutes. So first of all, we are talking about smart grid, then why we are talking about outages, right? And if we are talking about outages, that means it is really something big has happened. So when the utilities give this challenge to the meter manufacturers that the meters should be back within 3 minutes, I don't know whether the utilities provide this guarantee that their power itself will be restored in 3 minutes. Now, if the power gets restored in 1.5 hours, and then they expect that the AMISP provides the connection to the meter within 3 minutes, absolutely, to me as an outsider, as I said, it doesn't make any sense to me, right? So this is something which, when we show these kind of SLAs to our R&D teams who develop software stacks, I think these questions come back from them and we are unable to answer that. So I don't know, we need a separate discussion on that, but I don't know how much diligence is done in doing this SLA, but as I said, so I do not understand it. But the question here is, even if it is, okay, even if this is expected, or then why it is not for different technologies, right? Cellular, maybe you are able to meet all these SLAs, but we have to understand that RF mesh networks, right? We have to understand the technology behind it, right? How it works, how the neighborhood discovery happens, how the secure attach happens, how you basically use the public key infrastructure to actually authenticate the devices, how the frequency hopping happens, how different devices are at different frequencies, and how they get established and build a network. So it's a lot of technology behind it, and it takes a lot of time. It's when we are talking about 500 or 1000 meters which has to come in a network, right? It is very difficult to achieve this 3 minutes kind of requirement. So my sincere request is, again, to the utility people here, that please go back and look at these SLAs, whether they are unnecessarily or they are favoring some specific technologies only, and whether all the pieces of technologies have been taken, given a right justification for these numbers, right? So this is the key request here from this slide. The other thing that I want to talk about is about BLE. I think I spent a lot of time here. Nobody talked about BLE since morning, right? So apart from the cellular and the sub-gigahertz technology which is there, and we understand that nothing works perfectly, nothing works 100%, right? There are still issues. You can still have disconnections or maybe network issues, right? So it is always good to have a fail-safe option to switch to, right? And BLE provides a very nice alternative as a fail-safe technology. You can, so there are two things. One is the connectivity itself. the BLE can get connected to anybody's phone, right? So the meter owner's phone, the utility person's phone or tablet, it can get connected, and you want to disconnect, connect, you want to repair, you want to re-provision, all these things can be done very quickly with BLE. And so as I said, if any of the cellular or the sub-gigahertz network fails, right? So this is a very nice place to switch to. I still see, I go to all the meter manufacturers, I still see this optical plug. I don't know what is the need of that optical reader or the optical plug. When we are talking about smart grid and EMI, it disheartens to see we are still using all that kind of technology. So BLE is a very good alternate to that near field meter reading, right? And the key, and why we are saying BLE is because BLE is very, very dirt cheap right now. We can provide devices which are like sub-dollar kind of price range. You can get a semiconductor chip which can be a BLE SoC, right? So it's a very, very low cost technology as well as very, very low power technology. So your cellular networks, your sub-gigahertz networks will not work when the power outage is there. But BLE is something which will always work. It has a very low power consumption, so this can always work and always be there connected, even if there is a power outage because of the super cap or the battery which is there in the meter, right? So this slide basically talks about the reliability part, right? So if one technology fails, you should always move to a fail-safe technology, which is a nice alternative to the other things. Finally, I think, again, we keep on talking about SLAs, meeting the SLAs, which is a bunch of timing requirements, right, and getting the data out of. The thing that we are missing out here is about the security part. Security is prime important in terms of smart grid, right? When your grid becomes online, when the data of the grid, the control of the grid, connect, disconnect, everything is available, the access is available to everybody's phone, laptop, computer, it is a very, very important aspect. I work with a lot of university students. The level of knowledge in terms of security, protocols and all, which exists in the younger generations, right? It is very, very extreme. I think it takes just one person to get notorious, to get mischievous, to actually control your complete grid if you have not taken the security part very thoroughly, right? So the request here is, apart from focusing all the attention on the SLAs or all those things, maybe which matter, but my request is to give a lot of thought on the security aspects. We are building chips right now which are very, very highly, you can say, in terms of security, these are very, very highly secure chips that we are building. Be it sub-gigahertz, be it BLE, or maybe the metering chips. You can see I have taken the snapshot of one of our data sheets. This is the data sheet of one of our BLE SoC, and you can see the level of security that we provide. Now, in the whole security architecture, there is a term called root of trust, right? So this root of trust, when it is built on a semiconductor chip, this gives a big advantage to the whole ecosystem when you have the whole grid online. So you can see here the global platform level 3, the ARM PSA level 3. So these kind of security certifications, which are like very, very standardized in Europe, in US, right? So we provide these chips, and we can provide these to the meter manufacturers here, and you should actually use this, and this has to be taken very, very seriously, right? So these were the 3 messages that I wanted to give, and maybe I can take questions later. Thank you.
Thank you, Chandra. I would like to invite Shri Shashank sir, Joint Secretary Minister of Power. It is great to have you, sir, in this event, and learn from whatever the Ministry of Power is doing to bringing up the smart meter sessions. Sir, I request you to chair the sessions, and before the speaker, please share your inputs, thoughts into it. Thank you, sir.
So, do you want me to share right now, or should, going through the presentations we can discuss?
Sir, if you wish to share it right now, you can do it, sir.
So, okay, so let me, give a few initial thoughts and then we can proceed forward. So I think this entire day has been all dedicated to the smart meters, right? We started with the first session being on smart meter, then the second one also, and this is the third session. So definitely, I mean, ministry is very keen on pushing the smart meter projects, and this is why that is a part of RDSS. So almost 20 crore smart meters have been sanctioned under the scheme, and most of the works are now either awarded or in the process of being awarded. Whatever left over is there, and soon I think we are in a position to get a good number of these meters installed, because the pace is going forward, it is picking up very, very fast. However, we need to maintain that momentum. But there are certain key aspects, key issues which keep on coming in respect of smart meters. Obviously, there is a apprehension which the consumers have, that the meters are fast and all, and we've been doing all sort of things to bust those myths and to time and again say very strongly, that our smart meters are very fine and they are working very well. But still, these issues keep on coming. So that is one thing which we need to continuously work on and continuously hammer out the concerns related to that. Another is, creating a business proposition out of smart meters. So even now, I think, I think we have this session on data analytics. Data analytics is going to be a good portion of the discussions we are going to have right now. But data analytics is something which is still not very much a part of the thinking right now, of the utilities or of even the AMI ecosystem that we are developing. That would happen, but there is no business model being shown right now, being portrayed right now, that all these things can be done and all these things can be worked out. I've been in discussion with the AMISPs, which are working in the sector right now, that can we have some such models already being integrated into our application, our MDM, which can start giving certain insights, alerts, inputs, feedback to the utilities and to the consumers, that this is where I get to gain from the smart meters. Still that thing is, I don't know, I mean, still I don't see that visible right now in the field. So I've requested few of them, to start working on those, some of those analytics. There are a lot of solutions which are already existing in the market. There are a lot of startups which are working on certain solutions. But it's integration with the AMI, and AMI giving this, visibility to the DISCOMs and to the consumers that, this can happen. You can do all this. And this is the, business which is coming out of it. So I think there is still a lot to do. I also discussed recently with few of the AMISPs that why don't we integrate going forward the smart home applications with the MDM. That has an immense potential. And recently I have got a white paper developed, and I have shared it with the Bureau of Energy Efficiency. I'm going to have a joint meeting of the AMISPs with the these major smart home application owners, the LG, the Whirlpool, and all those association. So controlling your or getting to know the inputs of your appliances through your smart meter app, because they are integrated with the your smart home applications, getting to know the feedback for a consumer. I'm talking about getting to know what is the consumption which is happening right now, how can you lower your consumption, how can you alter your consumption, and using your smart home application which is integrated with the MDM to do all that. This is a business model which we can create. So there is a lot to do on the analytics part. Even the DISCOMs, if I say that you have now installed almost 6 lakh of smart meters, what are you getting out of it? Is there any, insight which is being given to you by those MDM applications? I don't know. Tejas?
Sir, we have seen just, sir, I speak up.
Yeah, so I mean, we have DISCOM people. So I would like to hear out if they are getting. And also at that level that we think, whether they are able to get something on optimizing their power cost, getting something of, or integrating them with their load forecast tools. Is that all happening? And if not, then when do they expect this to be in place? And our MISPs need to give that visibility to the utilities. Few utilities are more advanced than few other utilities. So they can still picture. What about the utilities which are not that advanced? We need to give them that insight, give them that that vision. So I think there is a huge potential. I mean, obviously smart meters have a huge potential going forward. All sort of renewable energy integration, all sort of smart grid concepts are based on this smart meter. This is the basic building block of all such sort of things. But that vision has to be now given to the consumer, to the utility, to all the stakeholders, that this is the potential and this is the economics out of it. So I think going forward, this is something that all MISP should work on and the utility should work on. And good that we are having sessions on these issues, and maybe something really good we would also get to learn from it. If there are certain modifications which we need to do. There are certain new technologies which are also being, the technology is old but the methodology is new. So the Bluetooth thing, I don't know why we are still doing with the optical character thing when the Bluetooth is there. I mean, somebody said that why are we doing the optical character thing? So I don't know. I mean, I would like to really hear it out from the meter manufacturers and the MISP. So what exactly is the logic behind all this? So good that we are having this session. Thank you, and thanks for inviting me. Thank you.
Sir, about the using the data of smart meters. So we have just picked up, but the first few 1 lakh meters, consumer meters, and 15,000 odd DT meters. Just last week we had a presentation from AMISP about the dashboard. So few things that we have just got is the loading on the transformers. So we are now getting the data where the DT meter is placed. So 10 to 20% loading, 20 to 30% loading, and all those figures. So we have identified some of the transformers where loading is more than 100%. So we are still into the going into minute details that how the data is faced and how correct it is. But I think that is the one use case that we will definitely use to augment our infrastructure. The second use case that we had used initially, as per the consumer pattern of the load. So we had identified certain consumers where there was a zero consumption for last 15, 20 days, 30 days, 40 days. So we raided those, not raided as such, we used for the vigilance part, and in few cases the homes were locked, but in few cases we actually found out that there was a theft. So it was one of the it is also one of the use case that we can definitely use in a larger way. So what we have decided in Gujarat DISCOM just recently, that we will have one small command and control center type of thing at each division level, where 1 or 2 engineers will be sitting there. And now we have NFMS, so there is a SFMS system where substation level feeder monitoring is going on, and we will have DT meter monitoring, and then consumer level meter monitoring. So we will get the data of each 30 minutes block, and we will try to get the data ki kitna power has been flown through substation and how much has been consumed. So whether there is a leakage somewhere. So based on that, we will definitely try to improve our vigilance activities. Though we already have AT&C losses less than 8 to 9% in all 4 DISCOMs, but definitely by using this data, we further will try to improve. So these are a few use cases that we are trying to get out of the system. But I think definitely with the new ideas, I think the people who are here may give us more ideas that how a utility can get the most of the benefit out of this system. So thank you, sir. Sir, I would like to request Mr. Rohit Pareek, Chief Product Officer of Impresa.ai, to give his presentation on this theme. Thank you.
Good afternoon, everyone. I was feeling sleepy at the beginning, but the tone for the session is already set. And Chandraji from technology provider side, and from DISCOM side, Tejasji, and then of course, Shashankji from ministry side. Particularly Shashankji's comment slightly, have shaken it a little bit in terms of how he sees it from the ministry perspective. What are the gaps in overall implementations and approaches and possible way people at the floor or the project level sees it, and then the way people at the ministry sees it, and how probably vision how they visualize it, and then whether those things are meeting it or not. So it's quite amazing to see what is being expected here. Tejas, particularly Chandraji, covered it from a technology provider side. A lot of challenges that he thinks are on the field side. And I'm being asked to do a theme session for what are the challenges that are being faced by Indian AMI rollouts. But being having a background primarily on the utility software side, I'll more focus on the software side challenges here. But of course, my co-speakers here have deep backgrounds and deep expertise in talking about field side issues as well, supply side issues as well. And of course, there's Tejasji touched upon consumer resistance as well. So there are a lot of these things that will be covered here. Without taking too much time, I'll start further. So that's how I titled it, Navigating Through the Challenges, and probably making it little future ready. Currently, most of the conversations that we hear are on making it ready for meter to cash. Immediately, that's the biggest challenge. That's what utilities are striving to make it work. That have you gone prepaid? Are you starting to collect money over there? That has been the challenge. Meter installation has been a bigger issue, but all those things will be talked about here. I want to also make a case for slight bit of modernization in the systems here, where you not only meet what is required today, but you don't want a situation where as soon as you complete your rollout in a year or two, by the time you become dated, and then you are not able to leverage the systems and data for anything else that you want to do. So here is a case for AI-enabled meter data systems. I'm not talking about the meter data management alone, but it's a holistic set of systems that are working together to make this happen. Yeah. We all have worked in this field and have our own opinions regarding what are top 3 or top 5 or top 10 challenges that are facing us. I thought these could be the one that encompasses most of the low-level topics that we see here. RDSS goals, I see from where I see it from, I think utilities have huge struggles in meeting those, and everyone is working hard, but then there are things that needs to be addressed there. Project delays and on-time go-lives, and someone mentioned SATs and other issues in last session. A lot of discussions happened in this regard, whether we do prepaid now, we do prepaid 6 months later, whether we be lenient regarding SATs and things like that. So all those are project level tactical moves that one can definitely make, but nothing can dispute the fact that there are challenges in going live in a timely manner. That also not only impacts the first one, RDS's goals and utilities objectives, but also AMISPs are here to realize the value of their investments, right? That also delays that realization of their value here. SLA challenge, everyone talks about SLAs, but it's really, really difficult to measure them and to meet them. And even, Tejasji, Chandraji talked about some of the SLAs, ambiguity around those, and everyone faces that. Now, measurement of those SLAs, who is responsible for the delays? RCDC, 3 minutes. Someone says, I did it in, say, 30 microseconds, but then others are taking 5 minutes. I don't know. So, I mean, how do you do all those things? It's very, very dubious currently. So, there has to be some profound mechanisms for that. And deficiency of future readiness. Misraji talked about this. Some of these things that he wants probably is some deep insights into what is happening today in the project. How many meters are live, if the meters are facing issues, billing issues are being faced. Some insights has to be there, and that's not a difficult task, believe me. Most of our AMI projects are not geared up to draw that insight from available data and then utilize that data to enhance or augment the effectiveness of their AMI programs. Most of them don't do that. Data just lies there. That is the current situation or current ongoing project status, and utilizing the information for that purpose. Say, for example, having a system called SMOC, Smart Metering Operations Center, right? It's not just a collection of some reports and dashboards and KPIs here and there, but utilization of AI can go a long way. Generative AI particularly, in not only telling you some pieces of information, some challenge there, but then also why that challenge has occurred, and then provide some prescriptions to you as to what you can do to fix it. Not only to the project level officials, but to DISCOMs level officials and to the ministry as well. And it's not a difficult thing to achieve, believe me. We have done it, and then there are things that can be done very easily in this regard. So if we try to address these 4 challenges, there are top reasons that I see why such challenges are being faced by our partners and AMISPs and ministries and DISCOMs. We are being drowned in the data. As soon as you meter start sending reads and data, we are being drowned in that. And then we just let it be there. And we struggle with files, and we struggle with sheer sizes of databases. If you have more than 1 million, 2 million smart meters sending you all the profile data continuously, it goes into terabytes very easily. And then you struggle as to what do I do with this, and then we don't really use it for any meaningful purpose here. That's one biggest reason why even the projects are struggling to meet their goals and timelines. Decade-old system architecture is the second biggest issue. Most of the meter data systems that we are using at this stage, they were architected in early 2000, 2005, 2009, 2010. That's when they were architected, and we are still using them. They were architected as if they are any other business applications, say ERP, right? The way you design a financial system or the way you design a human resource management system is not the same way you design a meter data management system. It's a huge amount of data that you need to deal with, and how you manage it, how you scale it up, scale it down on demand, things like that. Decade-old architectures are the biggest bottleneck here. And third, and I mean, there are many, many reasons, but I'm just trying to figure out what could be the top 3 here. So, fragile integration technologies that we use. These days, the technologies has evolved, but integration platforms and technologies we use are again coming from first decade of 21st century. And IT, OT, these are 2 disparate systems, very difficult to integrate because of the comms standards, and everyone has 100 excuses why it is not working, but only one way to or 2 ways to make it work. That is another one that we have to really And consequences, we all know, regulatory penalties are there, financial losses, frustrated customer, utilities. Everyone is frustrated in the whole value chain because of these issues, which are slightly easier to fix. One example, say, one of the systems, software system, is traditional, say, MDM system, right? Meter data management system, for example. Why traditional MDM systems are not able to cope up? Even the large vendors, traditional set vendors who we call tier 1 or top vendors around the world, their systems are again built in first decade of 21st century. Monolithic architecture, it's just one system. Scaling up, scaling down is very difficult. People claim to have horizontal scaling, vertical scaling, unlimited scaling, this, that. But yes, I mean, some of them can do it, but it's very costly. You don't want to scale entire system, you just want to scale that one service, right? And that, if you are able to do that, it's much cheaper than scaling the entire system. Lack of cloud nativity is also part of this monolithic architecture. Ministry and RDSS has very clearly laid it out, OpEx on cloud, hoping that it will bring down the cost per meter per month, right? But then AMISPs struggle with it. They are not, because of the monolithic architectures, cost struggles are there. And then even performance struggles are there that impacts SLAs and everything else. Those are symptoms, right? Siloed approach to critical business functions is another one. We see meter to cash as in several fragments of it. We don't see it end to end. Various portions of the software solution, they all talk about it separately. And some of the critical functions of RDSS SBD are not even part of the most of the vendors' standard solution stack. Say smart metering operation center. Everyone thinks that it's kahin ki eat, kahin ka roda type solution. You just bring this one here, some dashboards here, some fieldwork here. But it's not about that. It has to be part of your whole solution stack. It has to be, because without an effective smart metering operations, you cannot really be successful with your AMI journey. So siloed approach to critical business functions is one big issue. And how can you miss AI when everyone is using it for their benefit and we are not using it? For next 5 years, we don't even plan to use it in any of these systems that are being implemented. Now, if I go live in, say, Paschim Gujarat, for their AMI system, my contract is for next 10 years. I am AMISP. I meet those targets that were set to me nearly 10 years ago. Or 3 years ago, I will manage it as is for next 7 years. But 7 years, world will move somewhere. Our systems are not future ready, so missing AI advantage is a big issue here. And of course, I talked about traditional ways of integrations again. So these are some of the challenges that we have faced. Personally, I have done like more than 30 million smart meters under various implementations around the world, which amounts to nearly 3 crore smart meters. And that with that experience, I can speak for sure that these are some of the software side challenges that we have faced. Now that we understand why these things are failing, so what would be a future-ready architecture? What it is that we should do today to make it accurate so that we are ready for at least next 7 to 10 years? And we don't have to upgrade majorly or do major upgrades or do any of those new augmentation so that we are able to meet the upcoming challenges there. Any meter data system implementation, not meter data management system, but entire meter data management, entire meter data system that includes meter data management, prepaid engine, your customer engagement platform, your field work, and any other associated applications that you have along with it. Everything should have an AI first approach. It brings in the intelligence that detects anomalies and fraud in real time. You don't have to wait for tomorrow to get today's data and then do something with it. You can work on the data on the consumption as it happens in the field. Those are the possibilities that we are talking about here. Cloud nativity and edge computing, it eliminates your overload conditions. Scalability issues are handled in more efficient ways. AMI integrations, most of the meter to cache is just one use case for these systems, right? Distribution operation, which no one is still talking about, is another huge Pandora box that opens after you would have dealt with meter to cache. So integration of meter data systems with your OT systems is the biggest challenge. So that working with your OMS outage management, your DMS systems, these are the things that are going to come in the pipeline in 2-3 years, and then how do you deal with that? That is going to be a huge issue, so we have to be ready with that. Automated compliance, pre-integrated to RDSS specification, you bring in prepaid solution from there, you bring in customer engagement from here, MDM someone has created, errand someone has created, SMOC is missing from the puzzle. It creates a lot of compliance issue as well, and SLAs become hard to manage and things like that. Those are the things, if we fix in the future-ready architecture, it makes things easier on us. One of the, some of the suggestions that we had here are, this is kind of a reference architecture for an integrated meter data system, not really meter data management system, but meter data systems. And I personally worked on this one at one of the large utility in Middle East with more than 12 million smart meter in one instance. And utility itself has done a review by Gartner, and it was ranked #1 from all available options. That's why I can speak for sure that it has been peer reviewed and industry leaders have reviewed it. There are several elements to this. You see, left side, downstream systems are there, head ends and where meter data gets generated. On the right side, you see the systems that are consumer systems that consume this data for their own purpose. So there is first element, meter data ingestion that happens. Ingestion, there has to be pre-built, SIM-compliant, interoperable pipelines that are pre-built here to bring in the data from all required systems, not only from head-end, but then you need integrations with multiple systems to bring into your integrated data system, right? And it has to be done in a way the big data systems are designed, not in traditional way. ERP is designed. In any utility, if you see, size of your ERP data for last 10 years, maybe like 500 GB or 1 TB or 2 TBs. But for last 1 month of AMI data will be some 20 TB. So that is the difference we are talking about here. So you cannot just apply the same logic to everyone here. So meter data pipelines are very important. Then comes the central part where you process meter data, you store it, and you aggregate, you apply AI to some of these conditions here. What has worked with me is that most of the V rules and critical validations and things like that, we do it while we ingest the data right away. 80 to 90% of data doesn't have to go through your thorough investigation. 80 to 90% data gets finalized immediately, instantly for business use. Some 5 to 10% data may have some anomalies that needs to go through further grind. So you are able to use your data instantly as it happens in the field. So the processing of data with AI first approach is very crucial. Third is applications using your data. So in your architecture, you have to have these user applications. So meter data management is just one of the applications that uses this data to drive some of the business functions, say meter to cache and RCDC and things like that. Prepaid engine is another function. Customer engagement portal is another function, or which could be another application. And your field work is another application. Smart metering operation center could be another set of applications working together to make it happen. These are the applications. So it's a holistic data platform that gives you the flexibility of creating these applications and meet these business processing or business process requirements, as well as your other ancillary functions that you may need to carry out the operations here. Third or fourth, crucial, important, is publishing services. The data that you are building up here, the data that you are collecting up here may need or will be used by other systems, other consumer systems, your OT systems, your billing system and things like that. So ability to provide this data in a very reliable way. So you have to have publishing and subscription services available within the architecture that kind of makes it easy for people to subscribe to it and get it whenever they need it, not requiring too much of coordination with you. Currently, when you go live, billing happens, your billing system has to, 15 people are sitting in one meeting to make sure that every data is coming to us, and those things should not be required. In a reliable way, it should happen on its own. With this architecture, on a good day, no one logs into this whole system. Whole metadata management system, no one logs into it, right? Because everything happens on its own. So that is the kind of maturity we are trying to work up here. Now, using this sample or reference architecture, for example, what do you do? How do you implement a smart metering operations? Smart metering operations people see as very fragmented, siloed functions of field work or some KPIs and reports here. What Misraji was hinting at, that you not only have an operator UI for 360-degree view of entire business function that is being carried out in the field, but you also have next best action. So these charts and reports will give you issues. That my smart metering implementation rate has dipped down by 10% last month. But then what? Next best action, prescriptions is what we are talking about here. GenAI can give you prescriptions very easily. It's not rocket science, it's not difficult anymore. GenAI can give you next best actions, NBAs as we call it. Then using NBAs, they can even, some of those things could be, even implemented, executed. So not only analysis could be done, but implementation of those prescriptions could be done here. So in similar architecture, how a SMOC system works. It doesn't have to be outside your metadata systems. It has to be inside it. It need not be some other vendor SMOC you are bringing and then you are integrating it and then SMOC will work. Those things could also be done, but unless it is part of the whole thing, it's not going to be really working effectively. So again, 3-4 elements here that I already explained, and users are, of course, traditional systems here. At the end of it, what we have experienced, 75% reduction in cost of ownership. 75%, up to 75% reduction can be achieved easily. Metadata accuracy with AI processing is 99.99% accurate. 80 to 90% data is finalized right away. Flexible scaling on critical business days. Most of us, we have 4 or 5 billing days, not 22 bill cycles, right? 1 or 2 billing cycles. Those few days require ultimate scaling. So you don't need to scale everything. So scaling is one issue. And of course, the interoperability we have talked about. One example that we did was for 1.5 crore smart meters. And with 4-year-long roadmap, leveraging AI for business operations and customer service, and of course, operation costs are nearly 15% of the traditional MDM systems. So that's the reference architecture that I wanted to put out here, and we can definitely talk about this, and we need to hear more from our co-speakers here. Thank you so much.
So good. You had hit on the point on which I was also mentioning, that we need to think beyond this, and all sort of data we need to really work on. But certain challenges, crisis. In fact, you mentioned. So crisis is something which really raises my antennas, that what is the crisis which is going to, or what crisis we are going forward to. So maybe there are certain improvements that can be made, but would like to understand if that is really a crisis. Though I don't think I have time right now because I have to rush for Honorable Minister Sir's meeting, but this is something I would like to understand. More so, another thing that I would like to mention, that go live challenges, all those things. So again, I would come to the same point, that is creating a business vision for, see, if I understand that, next month, if I do something, I'm going to earn lakh rupees a month, I'm going to do it really fast. So creating that vision for utilities. Utility is going to earn this much. The earlier they do it, the earlier they get it. Creating this kind of urgency is what I think AMISP should create a vision for the utility. I don't know whether utilities are being given that vision right now or not. So if I know that, I just have to do it, that's why I'm doing it, then I would not be very keen to do it immediately or as early as possible. So I would request AMISPs to please create that vision for the utilities, because that would give a push to the utilities and also create it for the consumers, so that consumers are more so interested. Once this benefit is getting understood by the consumer, do it on prepaid or postpaid, it's not a concern for the consumer. If he or she understands, it's a great business proposition by installation of smart meters. It is going to give you so much of alerts, which is going to save you so much. But that vision is not there. Again, I'll say that vision is not there. We need to create that vision. We need to build that vision. So anyway, but thank you. Generative AI is something which we really need to push forward. And what I mentioned in the beginning also, there are a lot of applications already existing. Already a lot of applications are being worked on. So please integrate and try and create vision out of it. So thank you.
So we have next speaker, Mr.
Thank you. Just 1 second. I just wanted to thank Sir Shashank for joining us. I know you have a very, very busy schedule, but still you took out time. So please, ladies and gentlemen, put your hands together for Shashank for taking time out and being with us. Sir, we'll come back to you with the outputs of this session and share with you. Thank you. Sorry. Parmaji, you can continue. Thank you. Thank you, Phil.
So I'll invite Mr. Phil from Vice and Alliance for his address. I'll just request to stick to the timeline, so we have 8 to 9 speakers ahead of us. Thank you.
Thank you. Okay, so thank you all very much for the invitation to speak here. Many of you already know me. YSUN Alliance is about communications architecture. So I have several slides that talk about architecture, meeting SLAs, cybersecurity requirements, and touching on network management, which were the takeaways in the summary. So without further ado, YSUN is about wireless mesh. Following Mr. Goel's presentation, I think wireless mesh doesn't have to exist by itself. You can have heterogeneous networks, so in rural environments you might well want to use cellular. In dense urban environments, wireless mesh works very well. It's important, I think, to be able to, for the utility to be able to mix technologies, use appropriate technologies, but have a seamless view of these, whether it comes to metadata management or network management. So you'll see with the YSUN type architecture, we have a wireless mesh at the bottom that supports multiple services, so you can run your metadata or distribution automation, or even integrate with some smart city applications and water and gas. And they could be run by the same administrator, or they could actually be run by multiple administrations with a true multi-service architecture. And then the mesh network is typically last mile connectivity. Then you would use another higher data rate service to send that data into the cloud and to the utility back office. So we've talked a little bit about SLAs, and previous speakers have talked about how do you measure them, what's important about them, and I think it very much depends on what background you're coming from. I think number one is it needs to be reliable, resilient communication which works well in adverse conditions, and that could be geographical, so we've talked about dense urban and rural, There's also things like weather conditions that come into this, and certainly in parts of the world where you see storms that can affect things, or earthquakes or whatever. Architectural, as I mentioned, and then there's interference, which could be intentional or random interference, and cyber attacks. So it needs to be scalable. One of the things that matters is, can this network scale to millions of nodes, and how does it perform? We need low latency data transmission, and then latency is probably not highly quantifiable. Low latency is very different if you're looking at synchrophasers from smart meter data, or things like network recovery after an outage, which is the next topic. So how quickly does that network recover? And I know there is some interesting discussion related to wireless mesh. If you visit our website, there is an example of mesh reformation time, which I think meets the SLAs reasonably. So fault tolerance and detection and self-healing. So if a device goes faulty, or if a device is sabotaged, how does the network reform, and how can that be reported back to the utility so they can do something about it? I mentioned interference mitigation. We do see, even in cellular networks, how you end up with problems with too much traffic, or even intentional interference. And then most important as well is robust enterprise-grade cybersecurity. So for things like cyber, and within YSUM we use certificate-based device authentication. It's important to be able to verify the device. Strong link layer message encryption, so currently most people are using AES 128, but as Mr. Goel mentioned, AES 256 becomes important, particularly with things like post-quantum computing. And using AES prevents, the link layer prevents things like man-in-the-middle attacks, and additionally meets the privacy requirements. So also important is end-to-end application message encryption. So when you have networks that support multiple services, or when you have smart meters that support downloadable apps, so for example, Landis & Gyr Revelo meter, then you are potentially running multiple applications that have different security requirements, or different users and consumers of the data. So you need to be able to run different, they're not all encompassed with the same point-to-point security. Obviously, things like over-the-air upgrades are important. Like, I don't think anybody deploys a smart meter that first time round that doesn't have a bug in it. So you do need to be able to do over-the-air upgrades, and it's important that those meters support things like firmware signing, so somebody can't just hijack the meter, put some random code in it, and then infiltrate the network. So having a robust key management protocol is important, and it's important to support things like key rotation. So you don't necessarily have a single key that will last the lifetime of the meter. I mentioned interference mitigation, protection against signal jamming, and then another thing that's becoming important is things like network traffic anomaly detection. And previous speakers spoke about integration of OT and IT networks. If you're running an IT, so running IPv6, for example, on your OT network, you can start using the sort of tools that you would use for intrusion detection actually on the OT network. So when a smart meter starts sending sort of 15-second port scans, if you can detect that early, you know it's probably been hijacked. So this is a little bit of an eye chart. It shows how you might have reliable, secure, interoperable data exchange. And it actually shows a network topology that is being used in North America by National Grid, who are running electric meters and gas meters on the same network. In that case, the utility company owns both of those, but it's perfectly reasonable to run separate traffic for separate authorities on a common network. And here we also show that you can include things like pole monitoring, switch reclosers on the same network. Again, in North America, and I've shown some green meters and some red meters, there were supply chain issues during COVID. One of the North American utilities that was using Cisco and Itron was having problems buying meters. So they are looking at how do they integrate other meter vendors into the same network, either by having true interchangeability, which means common head-end system, or interoperability, where you can have two head-end systems aggregating into a single MDMS. And YSUM works with DLMS organization so that you can certify DLMS over a YSUM solution. So I know I'm out of time. I'll very quickly mention network management. So I think some important things: use standard protocol and object model. And there's a list of the sort of items here that that object model should support. And this includes things like registration, inventory management, and down to basically a whole load of items, including things like secure placement of large binary objects. So how do you do over-the-air upgrades in a timely and efficient and reliable way? So I know we've looked at multiple candidate technologies, things like lightweight M2M, OMA, which has been specified by Bureau of Indian Standards in BIS LITD 28, and things like CSMP, which is an IETF protocol. So that was it in a nutshell. Thank you very much. If there are questions later, then I'd be glad to take them. Thank you.
Thank you, Mr. Phil, for giving us insight into the YSUM field data network. Now I will request Mr. Ganesh Kashyap, CEO, to give his thoughts. I'll just request again to keep in the mind the clock which is ticking at the right corner of your presentation. Sir, thank you.
Good afternoon. Good afternoon. I am glad to be here with the esteemed panel, and then thanks ISGF for providing an opportunity. And then I'll try to keep myself, within the time. So I had the good fortune last 27 plus years part of this whole industry within Landis & Gear. I started with the AMR, which is probably like your AMI minus, and then from there we evolved into AMI 1.0 and AMI 2.0. So the journey has been pretty intense in terms of how it is. Like I had been part of several deployments, like large scale deployments across like Americas and also like Asia Pacific, including TEPCO. So I'll quickly give a glimpse of some of those. But my point is more around like not to dive deep into, because there are so many things there in the system that you have to take care. It's very difficult to kind of like put it all together in like 6 minutes. But I want to touch upon some key considerations that we have to take care. First and foremost, like again, this may look like an eye chart, but this is like a 50,000 view of how a AMI system architecture is going to look like. The system has several moving parts. That is something that we have to understand. Like, system is very complex. And again, the next slide also, I'm going to use it as a backdrop to see how the system and system intelligence is spread across. Because according to Carnegie Mellon study, this is ultra large scale system of systems. Again, the reason is because each and every single box itself is a system. And then now we are trying to bring together everything and then rein in and then try to build something that basically has to work in tandem. And again, it is almost like, we use the parallel to say that we all are digging tunnels and we expect everything to kind of meet together in a perfect way. Until unless it needs a lot of discipline and thinking through, it will not happen automatically. So that's where it's important. The key consideration here is don't try to think of this in individual parts. I know smart meter is a portion of this. Head-end system is a portion of this. MDM is a portion of this. You still have utility upstream systems, CIS, JAS, OMS, there are consumer portals. So there are a lot of things. The more system you bring on to the table, the more touch points you have, the more integration points you have. Now, when I talk about systems thinking, one of the most important aspects that we have to take care is today, you will not achieve perfect outcome until unless we retool our business processes. That is the key thing. Today we are doing things in a traditional way. When you are going to move into a newer systems, until unless you are adapting to the newer business processes, newer workflows, it's not going to work out. So you need to think of okay, I used to manage data this way. Tomorrow, do I need 90 days of data, 180 days of data? What am I going to do with the data? So once you start answering those questions, then you can say, okay, what kind of storage system do I need? Do I need a data lake? Do I need a near line of sight storage? How much of transaction volume I'm handling? Based on that, you can say that hey, this is going to be the size of my network and size of my back office, size of my load balancing capabilities. So a lot of these questions come out only when we retool the entire end-to-end business processes. That's where I call it everything in a simple parlance to say that it needs to have a systems thinking. And that we have to understand. At the end of the day, if the utilities have to achieve the maximum outcome, we need to bring everybody together and make sure that we understand what the business outcomes are, retool the business processes, understand the objectives, and everybody collectively put everything together so that it works perfectly. The other important aspect is the intelligence is distributed. It is not in one place. All the green items in the previous 50,000 feet view, they're all intelligent. Meter is an intelligent entity with the CPU, memory, has its own life cycle of its, it's got its own life cycle. You talk about the NIC card, it has got its own life cycle. Your firmware upgrade on the NIC card happens independently of the firmware upgrade on the meters. So until unless you harness the intelligence at various levels, you are not maximizing your outcomes. At the end of the day, if we piecemeal this, we are getting into a subpar design, and later on there will be so much of touch points in terms of doing the rework. Trust me, I have been part of several systems where we have done rework and then we have shot ourselves in the foot to recover from there. It is not easy, it is painful, it's costly for the vendors, it's costly for the utilities. So it's important that collectively we have to have that systems thinking to make it happen. So these are ultra large scale systems. So basically the most important aspect is if I have to sum it up, system design is very, very important. Harness the distributed intelligence. It's a crucial step towards grid modernization. Tomorrow, if you want to talk about a system that can manage the grid flexibility by understanding the various loads that's coming in from the metering data systems, then we need to design it properly. That's the ideal architecture. I am not saying that this is the ideal architecture, but the consideration for the ideal architecture is business processes, systems thinking, making sure that you understand what you're dealing with, and then harness the intelligence. So the next important aspect is the big beast is communication technologies. There are a dime a dozen communication technologies these days. Okay, we cannot box the communication technology into this one single aspect. Again, I will give an example of TEPCO when I talk about that as a case study. The communication technology concept should be adaptable. Don't piecemeal it. You need to have a holistic design. I will give you an example. Today, you want to have a quick win. You go stop dropping some cellular meters somewhere. You create pockets which basically will create a challenge when you bring some other communication technologies so that they can fill in the gaps. It cannot be done that way. It's not that easy. So you need to think through the entire system in a holistic way, bring all the communication technologies together, do a design to say that where I get maximum success with minimum cost. Look out that and then start rolling this out for the maximum impact, minimum cost, and then start picking the areas where you have to gap fill with the technologies that's basically suitable for gap filling. See, at the end of the day, the objective is to accomplish something so that it's cost effective, it's meeting the SLAs and providing all the business objectives. So that's the reason in the communications technologies, the key consideration is holistic design. It is all across the board, same thing with the routing, route planning, meter deployment. I have seen areas where meters have been deployed where there is no connectivity. And it took us months to troubleshoot why the meter is not coming back onto the head-end system at all. It's a lot of truck rolls, a lot of effort from vendor side, a lot of effort from utility side. So do the route planning in conjunction with the, how gateways are, wherever the gateways are populated, surround the meter deployment around that, plan it, work it out in tandem so that you optimize on all the truck rolls and workforce costs. That's very, very important. So from a communication technology perspective, the key consideration is holistic design, understand the nature of the various communication technologies and blend it in such a way that you are building an optimal system there. So other area is big thing is security. You cannot piecemeal security. You need to have an end-to-end view. This is spread across. It's distributed. It's churning in the protection mechanism across the board. So what we have to do is the consideration is to have a built-in data protection at scale. Okay, I built the security, what happens? Okay, there are areas where you cannot keep the security static. So you need to have provisions for rolling keys, rolling things. So you need to have certain tools and technologies to efficiently manage and govern these systems. It's not just one time I'm done and I'm dusted, I'm walking away, the security is going to stay there. No, the people who are breaking the security are way ahead of us. So it needs to be continuously upgraded, monitored, bring up to speed. So that's very, very important. And that's the main reason the most important aspect here is we need to get to an industry standard compliance security. We cannot go for non-standard proprietary mechanisms here. It's very, very important, understand the standards, build in the security, bring the appliances, and then build the trust through transparency so that everybody understands what's in there and then they feel it's secure and every layer is secure and every level is secure. So that's very, very important. So we have to provision for that. The case study, I'll come to this and give me one more minute and then I'll wrap it up. So TEPCO, why TEPCO? Again, in the first half, a few people made a reference to TEPCO. This is the world's largest IPv6 standards-based technology. Now, what happened is initially when TEPCO started, they started with 60% RF, 20% cellular and about another 20% PLC. Today TEPCO is 96% RF, 3% cellular, 1% PLC. The reason why they did is based on the holistic approach they took in terms of saying that where is the cost effectiveness coming in there? Which are all the mechanisms that work out for them in terms of meeting this, the various parameters of SLAs, their business needs and then the outcomes. So they started designing it holistically and then fine-tuning it. Today that network is 30 million endpoints on Wi-Fi compliant network, and then it has the capability of handling the traffic of another 30 to 40 million endpoints from various other devices. It's a multi-use network because it not only supports AMI, it also supports the joint meter readings, joint gas readings. So it's basically a very robust network. And I spent 36 weeks in Japan, in order to help out with all of this. It's a great opportunity for me. And from Landis & Gear perspective, we spent a lot of time to get this all right. Now we are in the second wave. The first wave of rollout is done, second wave of rollout is going on. So the key considerations that I have been talking about, we have been with the Japanese government and TEPCO and others have been implementing in this project. Again, every project, the success of the project depends upon making sure that we take care of these four things. Number one, systems thinking versus individual parts, design effectively to harness the benefits of distributed intelligence, plan holistically for multiple communication technologies, provision for end-to-end standards-based multi-layer security architecture at all levels. With that, I thank everyone for listening in, and then thank you ISG for providing an offer.
Okay, Mr. Kashyap. Next, I would like to invite Mr. R.J. Wala, Chief Engineer Projects, PGVCL. Please be crisp and short. Thank you.
Yes, sir. Basically, I am from a distribution company of Gujarat, and I will share my thoughts. That is, what should be the AMI version 2.0. Basically, as Mr. Rohit has correctly said, that the design we are implementing at present is nothing but the advanced version of the AMR. In 2009 it was designed, and at present we are using. So in AMI version 2.0, it should be future ready, so that we need not to replace it up to the 10 or 20 years. And we not need to do any retrofitting, like to invest any much cost on this. So for Gujarat at present, we have 10 lakhs of rooftop prosumers. So I have to connect all these prosumers with the smart meters to get the data for my day-ahead forecasting. So I have to connect all the generator meters of the rooftops with the smart meter, but I cannot connect it because the smart meters only have the connectivity, only have the communication, but the generation meter don't have. So any other device I have to put, and this will also have some extra cost. And then after, the next is peer-to-peer trading. So when this blockchain technology come and peer-to-peer trading come, I have to also invest some money on that. And then after EV. So after 5 years, there will be large numbers of EV charger at home as well as EV stations. So I have to measure all the data for my proper day-ahead forecasting, my energy accounting. So the AMI version 2.0 should have all the type of integration, and it should be at the home level, not at the MDM or HES level. As Jay sir has rightly said, that why don't you integrate the home automation network. So all type of devices, let's say today we are only thinking about electricity network, but tomorrow there will be a gas meter or water meter. So all type of whatever the device and number of devices, it should be connected with the smart meter, and the consumer will have only one app through which we can manage all our home automation network and all the data. And when the dynamic tariff will come, it will behave like a stock market. So we have to, MI system, this will enable all kind of, characteristic or mechanism, or in financial terms or in technical terms. So this MI version 2.0 should be future ready, and we need not to invest any much money after 10 years. This is my thought. Thank you.
Thank you for providing inputs from DISCOM side, because generally when the systems are designed, the DISCOM's view is taken later on after installing the systems. But I think he has made a good point. Now I request Mr. Shubhodip Rai Chaudhary, AGM, TP, DDL, to share his thoughts.
Good afternoon. Shubhodip this side. 4 questions have been asked today. They are ideal architecture of large AMI systems, reliable communication infrastructure to meet the SLAs, measures to ensure cybersecurity, and of course, NMS and SMOC. Today, I think a lot of word has been spoken about usage of data and the business cases that can come out of it. 40 such business cases have been submitted to Shashank Sharma sir's office on 24th of September. They're working on it. And once they decide what are the ones they want to implement in India, that will get implemented. We are a small utility in Delhi, Tata Power Delhi Distribution. Tata Power owns 51% of the same and 49% by government of Delhi. We have been making profits consistently. In last 22 years, we have also made losses only in 3 quarters, sir. Not even a year. So that's how our balance sheet looks. This is the number of people that we serve, and this is the peak load. This has been updated last. Along with this, add 11% load growth, which we had in the month of June. So looking into that, if in case we go ahead, This is what we have done this year. We have successfully met load of all-time high, 2481 for us. All-time high billing efficiency, 94.5%. 5.3 lakh smart meters done. Going by quality award, we are the only utility, not in India. Not in India. Even TEPCO doesn't have a Deming Award. We have got the Deming Award in quality, and in Global Smart Grid Index, we are at number 8 now. From India at number 8. The score looks this way. That is where Tata Power DDL is. We benchmark ourselves with TEPCO. TEPCO has gone ahead this time. Last time we were ahead. Our main problem is coming out to be data analysis. In data analytics, they're speaking about smart meter coverage. 2 million consumers, 5.53 million smart meters installed. Why not more? Government hasn't allowed. The day government allows, we will be doing more. And going by the AMI architecture that we have in India, this is where we stand. And I think it's a matter of pride. And with matter of pride and confidence, I stand in front of you and say, if in case you emulate us, Indian story will be done. That is the reason why when ease of doing business had come, only 2 utilities in India were selected. One happened to be us, one was Adani Mumbai. So, India started from 95, ended at 18. And then they stopped ease of doing business calculation. Anyway, I agree with Ganesh sir, Ganesh Kashyap sir, something that is a change of heart for him as well and learnings for us as well. Only one technology will not do us any good. There is a word which says horses for courses, right? And we are looking forward to one technology additionally, and this is something that we had taken from them. Sub-gigahertz technologies on their RF. But being truthful, that did not serve the purpose alone. Along with that, we have installed NB-IT meters, 4G meters as well. And now presently we are looking for in-meter gateway. If in case you have an in-meter gateway, because business cases will go granular. When business cases go granular, you will need the interval data mode. In our tariff meter standards, whatever standards we have, edge of the grid cannot be done. Edge of the grid is done on 101 protocol in our utility, and that's a separate application altogether with OEMs and SIs. So, under the given specifications, once you are asking AMISP to do a certain job, his job is to deliver what is written on the paper. And this is a madman slide which we love. We drew this one up in 2012. 2023, 100% implemented. 100% implemented. You name the business case, implement it. Along with that, as sir was saying, we are looking for a card which has multiple backhaul. The best part which happens with your RF and your NB-IT is small things which we like. We don't like sending people, our meter readers, our people to people's homes because they do not like us much. They think that we will disconnect the supply or whatever. The thing is, over there, you don't have to cut the seals if in case you are using these technologies. If in case there is a non-com in a 4G meter where you have to change the SIM, you will have to cut the seals of the meter box. And whatever data support you give to the court asks for physical evidence of tamper. And seal is still the best thing. So therefore, putting the madman at rest, this is what we have implemented. You tell me, sir, what you need. There is not a single utility in the globe which has furthermore implementations. Because given the kind of meter that you have, only those business cases can be replicated. Scalability, well, what we have done is in scalability, AMI deployment in RF, this was done using L plus G, of course. And then for all cellular technologies, we have only one HES. 2G, 4G, NB-IoT, XIoT, whatever you bring, all of them will come to this HES, depending upon the latency of the network. If in case your HES is not good enough to pull, I disagree with one idea that MDM will do everything on its own, you don't have to put your hands on it. That means, is the data coming on its own? Or are you pulling it? If in case you're pulling it, that means you have a pulling software. And whether the pulling software is working correctly or not, you need to monitor. If in case you're not monitoring it, either you are not doing your job or you have employed someone else to do that. As simple as that, sir. Measures to ensure cybersecurity, well, philosophers have defined the world in various ways. The job, however, is to get it done. Simple things first. Over here, whatever you do, OT devices, IT devices, all of them have to be configured, applications integrated, your penetration test of your things to be done, vulnerability assessments to be done, but the penetrations have been very few. In our CNET, as we call it, our IT and OT platforms we have segregated in multiple ways. Because meter reading data, you do not need for regular operations. Because as per our Indian specifications, meter reading data will come to you 4 hours later. Can you run a SCADA system on it? No, you cannot. So therefore, that part becomes much easier. 1 minute left, you said 7. And this is where SMOC and NMS stands. A bit of pictures, events, notifications, analysis and verification. That is what you continually do. And this is for data outage management. This is what we are continually working upon. And the key takeaways are supply reliability. We are here to sell power. That is our primary job. And if in case a consumer doesn't have power, it's meaningless. So the business case, you put all business cases at one side, and the 7 minutes which I have been allotted is actually the 7-minute reduction plan with which we started in 2012. If in case unserved energy per consumer is reduced by only 7 minutes, the entire cost of the project recovers itself within 5 years. As simple as that. So, if in case you do your primary job well, everything else is done. Regarding DR integration, well, yes, everybody is liking your distributed energy now, solar, it's becoming cheaper. Just one input. Net metering will become history in 10 years in India. Take it from me. It is history in US, in Germany, even Indonesia. So, mark my words, get your integrations done well. Even in India, we have said, it's not regulations now, it's guidelines. Along with solar, put a battery up. Why? You understand better next time. Thank you.
So, thank you, Mr. Shubhadeep, for showing the successful use cases that you have implemented in Delhi. Now I will request Mr. Partharthi Krishnan, Executive VP, Hardware and Firmware, to give his address. Thank you.
Good afternoon, one and all. Thanks ISGF and my company Cyan Connaught for giving me an opportunity to present certain thoughts on the smart metering part. So much has been spoken about the architecture. We are at the age where the utilities, solution providers, policy standards all speak about one thing. We are very clear about what needs to be done. Just to start with a quick slide on who we are. We just try to be one of providers to be a one-stop AMI solution. With the experience culminated over by implementing AMI projects across 15 plus states and with different AMISP providers and with different smart metering partners, we would like to emphasize, or we would like to pitch the idea that one cap size doesn't fit all. This is what should be followed. In an ideal AMI architecture, it should be a hybrid technology that should be brought in. Yeah, one technology might work for one utility, it may not work for another. That is why we need to have a hybrid. We all have heard about RF technologies, cellular, PLC and everything. With the recent introductions, we are one among the other solution providers who pitch in for in-meter gateway as well. Because there will be a pocket of meters where it will be the quantity or the clustering size will be very small, wherein deploying a gateway or cellular might not be cost effective. So in-meter gateway is where you have a hybrid communication built into the meter. And from our side, we have made such that even in case if one technology doesn't work, say for example, in the event of a failure on the cellular side, the RF side will take over. The meter will try to find its neighbor RF mesh network so as the data can be pushed. Because at the end of the day, SLA matters to the utility. And based on the SLA, the AMISPs and everyone gets paid. While the entire gambit of AMI ecosystem, starting from meters, communication technology, including the cellular service providers, cloud service providers, hidden systems and the northbound systems like MDM, billing, everything is there. My emphasis is mainly on the devices side, that is the devices that have been put into the field and how that plays a crucial role. Another thing that we have introduced is the long range RF. Like while RF beautifully works for urban sector, when there are big utilities where they have distribution both in urban, rural and everywhere, there may be areas where the cellular coverage is not possible at all, or even say for example fiber optics at the substation level. So this long range definitely helps there. And what we have tested is with a pure line of sight, long range it operates for example 9.8 kilometers. But however, when we deploy that in real field, due to the RF attenuation, due to multiple environmental factors, even if you are able to achieve, say for example, data communication for up to 1.5 or 2 kilometers, it is well good enough. It offers lot of benefit to the utilities at the end of the day. And we have also introducing the gateways, what we have regularly with both capacity to work with the short range RF and also with long range RF. So in gist, so what we would like to, I would like to reiterate is that one cap size doesn't fit all. Obviously, it has to be a hybrid communication technology that the utility has to opt. Yeah, and the other theme or the topic for this session is the security model. Yes, while we have different technologies, communication technologies, or even when systems are integrated, we follow the simple Swiss cheese model where security has been implemented in all the layers, starting from the physical layer of the communication device and up to in session layer, transport layer, up to the application layer. As I said, I am trying to focus on the certain elements that are on the field side. Today the panelists also spoke about using different changeover mechanism. Say for example, Mr. Goyal spoke about the use of BLE. Now that we see it as increasingly being adopted across the industry. Say for example, when RF or the cellular doesn't work, why not the Bluetooth, which doesn't depend on any cellular or some other thing, can be used not only for data collection, but also to accomplish any critical commands like connect, disconnects, or even if you want to change the configuration of a meter, that can be used. As I said, and also much has been spoken about of using of AI, and also how edge computing can also play a crucial role in meeting the SLAs. As we know, that devices that are in field, we call them as constrained devices. It means the processor that has been used on the nodes, on the gateways, have limited memory computing capability. So how do we efficiently utilize that is one of the challenge that a developer will be facing through. And second point would be on the network redundancy and reliability. Now with all the SBDs, what we usually see is that the gateway should have a dual SIM. And now I had a very good opportunity to meet some of the vendors here who offer multi-profile on a single SIM card. You don't need to have a dual SIM port. Okay, you can save even cents by eliminating the other SIM card holder. Just with a single SIM, you can have multiple profiles, and you have the flexibility to change between operators in the midway. So that is one of the things that the industry can look into for adapting this. And next important factor will be the self-healing network. Yes, obviously most of the RF solution providers have this. There is another important factor that mainly in RF, though the standards everything says, but how does the interference play a major role in the field? So as we know, there are with multiple RF devices with cellular networks, everything, interference is a challenge to the comms provider. So there are certain advanced techniques like using adaptive transmission power, where a device can utilize only the required amount of power to transmit so that it doesn't create noise to its own network and also to its surrounding. With that, I will just end my topics here. And thanks for this opportunity. And also I would take this opportunity to invite you all to visit our booth number 9 and 10 so that you can experience the different solutions that we have. Thank you.
Thank you, Mr. Parsati. Now I request Mr. Gopinath Misra, Product Manager of Digital Solutions of Kimball, for his address. Thank you.
Yeah, hi. Good afternoon, everyone. So, currently we are witnessing a massive transformation in all the segments that we interact currently, right? So, consider ourselves as a child, small child. How do we learn actually things? We observe, we experience, and we adapt to the situation, and we continuously change ourselves to learn new things actually. And whatever we learn, we try to improvise on those things. Similarly, we as a utility, we are also witnessing major changes happening in our system. So there are a lot of new disruptive technologies that is coming on. And what we are focusing on is like, can we get the experience out of that? We change our business processes accordingly. We see like where the integration is failing or what are the challenges in the integration. And based on that, we adapt to ourselves. So it is inevitable, right? So these disruptive technologies will be there and we cannot get rid out of that. We have to adapt to that situation, and it is, there is absolutely no other chance that we are with at present. Then the first thing is like this smart metering. It is purely revolutionizing the entire distribution utility. That is a no-brainer, right? Then coming to the next, that is with new innovations coming into picture, that with advanced metering systems that will come in near future. So a lot of grid analytics and the proactive grid maintenance and everything that is going to be there. At the same time, there is one segment that is we are ignoring at present, that is the customer engagement, or we can say it is a citizen engagement, that we are missing at present. But they are really the crux of the matter. Like if they approve our system, then they will definitely use that system. So there is a kind of trust we need to build with them. So then the third part is like we are given with multiple technology options, right? But that system should be scalable enough, then it should be interoperable, and it should be cyber secure enough. So then the next system is it should be aligned with the existing business process of this utilities. It is not like we should be working in isolation, right? And the second system is like it should have a seamless deployment and the operational, it should increase the operational efficiency of the systems, overall system, right? Then if I look at the current smart meter deployment, that is purely what we are doing, right? We are getting the remote meter readings, right? And we are collecting the data. In some sort, we are giving the information to the consumer, maybe offline basis, something like that. And the utility, what they are doing, they are just doing the remote operations actually and doing some kind of configuration changes in the meter. Other than that, the system is sitting idle actually, right? But with the transformative approach, say 1 year, 2 year, 3 year or more down the line, so this will become an edge device actually. With the advanced smart metering deployment, it can be an edge device. We can consider it as an edge device. And with that information, we can give a lot of information to the end user so that they can use it and they can change your, that there is a trust between the utility and the user. So whatever you want to communicate to the customer or the user also perceives the same thing and interact accordingly. Then currently, if you look at the primary challenges that DISCOM faces with respect to the integration with any system, like be it their ERP system or the billing system and their outage management system, then there are a hell lot of systems that is there inside the utility. So there is an integration challenge, there is a cybersecurity challenge, and they need a cost-effective deployment solution. So that it will be a win-win situation for all the things actually. So this shift requires a strategic investment in the scalable architecture building that aligns with the existing systems as well as the processes. So when I talk about the scalable architecture, that means it should be scalable enough to serve the purpose for next 20 years or 15 years, something like that. It is not like 5 years, 6 years down the line. Because eventually, whatever the system we are deploying now, that will be valid for next 10 years or 15 years. But what beyond that? So why advanced smart metering matters? There are multiple stakeholders engaged in the system. So one of them is the consumer. So what they need, just like us, like we need 24/7 power, and that to be qualitative and reliable power, right? But in most of the systems, in India especially, if you look, this is a luxury to most of the people. And similarly, the second aspect is the citizen engagement. And there I am talking about purely trust building with the utility and the proactive communication that we need to give it to the customer or end consumer. Similarly, the personalized insights, alerts and demand side response program that we need to engage them in future, right? Then the second is that we need to also support proactive maintenance, the minimizing the outages and improving the response time. So I'm just giving a perspective, like in any HCS or something like that, there could be roughly around 2 million smart meters deployed in the system, right? You can generate a service out of that so that you can give a suggestion to the utility that I can control so and so loads actually. So if you need any kind of, say, load shedding options, then give me an option. I can help you out in giving that solution to you. Similarly, most of the utilities, they are coming up with this DR integrations wherein mostly this renewable segments and the EV charging units will be coming into the grid itself. That is very uncertain. Like we need to see like how this system is changing or changing the behavior of the entire grid. Then the key features that is needed at present is like the enhanced data granularity. So what I mean is like delivering near real-time updates for monitoring. Suppose the HCS system or say any system is capable or meter is capable to send the data every, suppose say in real time. So does the HCS system or the MDM system has the capability to process that data? So that is the next part is the swift data processing. And third part is the interoperability, cybersecurity framework then the edge computing, and the advanced intelligence. So how this thing can be built actually? So for that actually there is a need for a scalable platform, right? Without scalable platform it is practically not possible. And it should be cloud agnostic, that is, and when I talk about cloud agnostic, again there is one part, like you can deploy it on-premise or any cloud. Then the second part is like you should have a device interoperability also, right? And the real-time intervention that is also needed, especially if you want to interact with the customer, end user. Then it also needs to enhance edge processing. So currently our meter is basically, or say any other meter that is present in the system, that is a limited processing capability. But going forward, say 5 or 6 years down the line, when the electronic cost will be very minimum and the processing power is good, then you can have edge processing capability also. Without edge processing capability, you can do many things. Actually, you can do many wonders in the system. Then obviously the last point is that legacy integration. That is still there. It has to be there. It will be there. You cannot avoid that. It is inevitable in the system. So coming to the roadmap, it is the ecosystem collaboration, wherein when we say we, that means every person in or every entity in the entire ecosystem, be it utility or the AMISPs or meter OEMs or the communication OEMs, they all have to foster partnership among each other and give a beautiful solution to the utility and the consumer so that they can get a win-win benefit from all the cases actually. Then obviously in the backdrop, it needs a holistic planning or the end-to-end planning to have it, to implement this system in a very effective way. Then the data analytics and the trust-based engagement that I was talking about along, with your customer actually, end user, that is primarily important. And when I talk about the new DR integration, the EVs and the renewable segment, then it needs a future-proof system wherein you can integrate all these emerging technologies that is coming up in the system, because we cannot avoid that. It is going to be there actually. With this, I am basically closing this session. Sorry, closing this presentation. Thank you very much.
Thank you, Mr. Gopinath. Now we have 3 presentations left. I request Mr. Lalit Rao, President Appleton, to give his thoughts on the.
Good evening, everybody, and thank you ISGF for giving me this opportunity, and especially to present in front of this most erudite panel with likes of Mr. Shubhari, Prav Chaudhary and all, who are like the mentors of smart metering in the country and one of the brightest minds. So I'm pretty humbled about this. Thank you so much. I'm here just to present my company and just to give a brief introduction about our facility. I think all of you all have had a holistic approach towards architecture. So Appleton has come a long way since 1977, right from humble beginnings to fully integrated R&D team, SMT lines and NABL accredited labs. We have now emulated and to be answering one of the issues raised on Bluetooth, BLE enabled. So we've come out with the latest meters with BLE enabled in the NIC also. So, and I mean, we are very grateful to people like Mr. Butola and entire Tata Power team who have kind of incubated us in their vendor development program and have been kind of, mentoring us on the R&D front and giving us good ideas. Mr. Sandeep Dhamija, who has monitored our meters at ground CSP DCL also. We would like to take this opportunity to express our gratitude to IntelliSmart as well, MD, SCM team and Mr. Vijender Malik, who is present here with us. Without his, they've given us the most complex solutions to make our meters even more robust. Just to be, everybody is aware of the robust growth and escalated this thing of smart meters being implemented globally. The demands are rising from, I think, about 1.7 billion in 2023 to about 3.4 billion targeted 2027. The governments have all racked up whatever they can do at their bit, along with likes like ADB, as well as they are rolling out schemes like the RDSS, which has been globally accredited and recognized for its meticulous implementation. There has been, considerable consumer resistance since it's a new technology. It's where the monitoring of the energy starts from. So, but gradually things are coming down, and people are in acceptance of it at the grassroots level. Well, now the smart meters, when it comes to the utilities, smart meters are enabled with fault-finding devices and outage management systems, making things even more resilient. And the HES and these things are all integrated with such efficient features. One thing that probably we should pay attention to is also the EV to grid utility of the smart meters, which helps the to and flow of the meters, and it also brings down, it also helps the consumer reduce their cost of consumption. Overall, smart meters globally has definitely has changed the consumer pattern of consumption, as well as made consumers more conscious, as well as the utilities are much happier in terms of security, fault detection, and fault solutions. So overall, smart meters improve the customer engagement with advanced analytics on smart meter data, making them even more aware on the energy consumption patterns, and thereby helping them on saving their bills with TOD. We are trying our level best with the blessings of Tata Power and likes to emulate our meters to the best standards possible, and to keep up to national and global expectations. Thank you. Thank you.
Thank you. Now I request Mr. Amit Bansal, if he is present. Okay, yes. So DGM metering of NPCL.
Good evening all. So thank you jury, thank you panel members and audience for the patience listening till time. I'll not take much time, I'll conclude within 5 minutes. A lot of speakers have already spoken upon the AMI 1.0, what all is there, what should be the architecture, how the things are moving. So I'll just touch upon the AMI 2.0, what the tone has already been set up by Mr. Misra, Joint Secretary Sir, that we need to go beyond meter. So for AMI, when we are talking that the primary aspect of AMI 1.0 was on the automated meter reading, improved billing efficiency, and introduction of analytics with regard to the smart meters. And when we are talking about AMI 2.0, probably we need to shift our focus towards the consumer centricity with improving the operational excellence, duly consideration, the decarbonization, decentralization, and grid resiliency. So the basic architecture, when we talk for AMI 2.0, probably the core competence and workflows are similar to AMI 1.0. For AMI 2.0, we need to go for edge computing, advanced capabilities, real-time data. Currently, we are getting data for after 4 hours or maybe 2 hours. Probably we need to get more data more frequently after 5 minutes or 15 minutes, so that we can build our system and build our analytics more strong. And interoperability is one of the major aspects, and scalability and the cost effectiveness. So the key functionalities of AMI 2.0 would be, it should be real-time data analytics, two-way communication between utilities and customer. So probably when we were talking about AMI 1.0, we are talking the communication of meter data with utilities, and the communication is between the meter and utility. Probably in AMI 2.0, we are touching upon the consumer as a whole, wherein we can regulate the consumer ACs, we can regulate the e-vehicle charging mechanism, we can regulate the consumer home automation and things like that. So we need to enhance the integration with DERs. We need to improve the consumer awareness about the consumption, what they are consuming. Edge computing, we need to support microgrids, load disaggregation. Probably Mr. Rao has also touched upon the load disaggregation part, that how we can identify that based on the wave curves, what type of load consumer is using at any moment of time. And it should be a control gateway for various DERs so that we can optimize our network. I'll cover in detail. So this is the basic architecture for AMI 2.0. The basic is almost similar, but in addition to the smart meter with my HES and MDM, probably backward integration is there. Maybe it could be through Bluetooth, Wi-Fi, Zigbee, wherein we can integrate with the consumer HVAC system, the lighting control, your home appliances, probably the distribution energy resources we can also integrate and regulate through the system. So for communication infrastructure, Mr. Ganesh sir and other team panel members have already spoken a lot that one communication technology cannot suffice the complete AMI architecture. Probably we need to go for multiple communication strategies. So I'll put my more focus on the use cases, why we need AMI 2.0. This is the typical e-vehicle depot, bus depot charging profile. If we see the gray pattern, it is the off-peak hours, and the pink pattern is the peak hours which was given by the regulator. So if we see that almost 66% of energy at e-vehicle charging depot are being done during the peak hours, and only 1 to 2% consumer is taking the power on during the off-peak hours. So the balance around 30% is on the normal hours. And if you see the red curve, probably it is coinciding with the daily peak curve. So managing the peak power plays a very important and key role when we are implementing the AMI 2.0. So during the off-peak hours, we need to regulate the chargers so that we can put the charging of the buses during the off-peak hours, and during daytime, probably we can put the battery energy source system or things like that so that we can cut down the peak. Another use case with regard to the network optimization, like as the EV penetration in across Delhi NCR is increasing, and most of the times things that happen, then when I go at home at 8, 9 o'clock, probably I just go and plug my e-vehicle into the network, and that is the peak time up to 12:30. Probably in addition to my ACs and all, my e-vehicle charging infrastructure is also there. So definitely, if I don't go for the e-vehicle regulation with regard to the charging infrastructure, I need to upgrade my infrastructure by at least 30 to 40% across the area of geography. So we need to regulate this through the AMI 2.0. Another point that we need to engage the consumers, that yes, if you are using the off-peak consumption, and if you use more energy during the off-peak hours, probably your energy bill can be reduced, and regulatory framework need to be strengthened with regard to the incentives on participation of demand response, and we can also ask consumers or incentivize the consumers so that they can contribute to decarbonization. So the key takeaways or recommendations are with regard to the regulatory framework strengthening, that DR incentive should be there, time of day tariff should be there on e-vehicle tariff, power quality they should come up, and e-vehicle to grid they should promote. With regard to MDM providers, probably the enablement for the utility should be the DERs, load management, EV to grid energy management, and consumer load disaggregation. And another key aspect with regard to the AMI 2.0 is with regard to the interoperability with other smart grid operations. Probably we need to integrate with smart grid, and IoT integrations should be there. And one thing we need to ensure that as we are at a very mature stage of implementing AMI 1.0 across India, probably we need to prepare ourselves from right this moment so that we can put bare minimum cost to go for AMI 1.0 to 2.0 so that we can upgrade our MDM, HES or meter infrastructure at bare minimum cost. Thank you.
Thank you, Mr. Amit ji. Now we have the last speaker of the session, Mr. Rathinasamy KS, co-founder in Through Technology.
Hello all, good evening. This is Rathinasamy and I am the co-founder from the company called Entutech. So basically, this company is from Coimbatore, Tamil Nadu, and also I represent the LoRa Alliance. So where almost 600 plus members globally part of this alliance. So I would like to give a quick intro about the LoRaWAN as a technology. So basically the LoRa Alliance has been initiated from 2015, and since from the inception, there are multiple global giants are part of this alliance, and the technology is continuously evolving and it is contributing to a lot of sustainability solutions and the smart metering and a lot of solutions across globe. So the LoRa Alliance is the the central body where it is developing the standards, and the standards is suitable for more and more solutions across globe. So this is basically a small architecture where how the LoRaWAN is integrated with DLMS as a technology, and how the DLMS meters can be deployed across the verticals. So this could be utilized in the smart metering segments, or it could be utilized in the sub-metering segments, or the multiple utilities like energy, water and gas utilities. So basically the LoRa physical layer is communicating with the LoRaWAN gateway, and from there the SCHE gateway and the IP connectivity is coming into picture. So currently these kind of DLMS energy meters are being deployed across the globe with LoRa Alliance LoRaWAN enabled specifications, and currently in India we are also pushing to deploy these kind of DLMS enabled LoRaWAN meters for multiple states. So basically the alliance has developed multiple standards and the adoption layers, how to adapt this DLMS along with the LoRaWAN, because the LoRaWAN is already adapted as one of the technology for the smart city use cases, and ultimately the moment we are bringing into the metering also as part of the LoRaWAN and DLMS, then it would be more scalable across. So I would like to mention, for example, here I think the esteemed panel members and everybody is talking about multiple technologies, and also how the BLE is supporting for the metering, and also how the multiple technologies can be integrated to give a holistic solution for the community. And ultimately LoRaWAN is also part of that initiative, and already the LoRaWAN is working along with the BLE, and it works along with the Wi-Fi and other technologies as well. So basically this is more secured enough to have the smart use cases, whether it's a metering or it's the other solutions, community oriented solutions and all. And it's very much interoperable, and there are a lot of device manufacturers and the network service providers. For example, the Tata Communications is one of the biggest LoRaWAN network service provider in India, and it's very hugely available across globe to cater the small use cases and up to the big large use cases. So here I would like to represent some of the success stories that Entutech has done in the last 8 years. It's all like some are the small use cases and some use cases are big. But ultimately I would like to mention, like as sir mentioned, we have to move from 1.0 to 2.0 where we are really utilizing the data and giving some meaningful solutions to the community. So that we are doing it, for example, whether it's a small community or it's an infrastructure facility or it's an warehouse. So we collect the data and then we provide the solutions to ensure the more sustainable operations across their value chain. So basically this use case we have deployed in Bangalore Airport City Limited. So where the water usage from source to consumption, it is 100% monitored with the LoRaWAN enabled meters, and as well we do the complete data analysis to provide customer to ensure their the operation with the better water usage. So basically we have the proven track record with them. We have saved the water of up to 10 to 12% for them for the last 3 years. So where we are deploying the same kind of use cases for multiple the community buildings across Bangalore and Hyderabad and other cities. So this is the other one important use case that I would like to mention. So where we have deployed the smart energy meters in BRB NML. So BRB NML is the place where our currency is being printed. So there is an officer quarters. Basically, it's almost 1,600 officer quarters where they wanted to optimize the energy usage. So what we have done, we have established an LoRaWAN network across their campus. It is almost like 100 plus acres of campus, where we have deployed the gateways and we deployed the LoRaWAN energy meters. We start collect the data for every 1 hour, every 2 hours, and then we start provide the insights where the energy leakage is happening and how the energy can be optimized across their usage. So this is one of the biggest use case for us. So we have deployed more than 2,500 meters along with the energy and water meters. So this is another use case. It's almost like spread across almost 250 acres in Bangalore, and it's a very prime, the villa which is located near Whitefield, Bangalore. So the thing is like here customer doesn't want to touch only energy or water. They also want to ensure to optimize their operations across the verticals. For example, the common infrastructure and VFD systems and pump systems and what is the level that borewells are being maintained. So basically what we have done, we have deployed the network and we deployed different devices which are capable to communicate with LoRaWAN, and we collect the data and we provide the optimization to the customer. So basically now as a result, just 6 months is over, and we can able to achieve 5 to 6% savings in the maintenance cost, and also the water reduction is highly expecting between 10 to 12% in the next 6 months. So this is another use case, and this is one of the use case that I would like to highlight more, because this I think we all know about Zomato. So yes, they have lots and lots of the delivery centers across India. So basically what we do with them is they are operating the cold rooms, and the cold rooms are one which is consuming more energy. So basically what we do the optimization with respect to operating the cold room, and as well we do the temperature monitoring and throughout the supply chain. So basically this solution has been deployed across India for almost 47 locations for their warehouses, and currently we are scaling up it to the dark stores. So we started working with multiple, the quick commerce deliveries people as well, how to optimize their energy usage and also, optimize their operations. So these are some of the use cases that I would like to highlight that Enthutech has been done along with the LoRaWAN as a technology. So I would like to expect some questions from you. Thank you. So just to remind, so we are available in the booth along with Tata and Semtech and Kerlink and other Ripple meters. So please do visit our booth. Thank you.
Thank you, Mr. Rathinaswamy. With this, I think we have come to the end of the session. We had interesting points from DISCOMs, from AMISP and other service providers. So I would now request to end the session with thank you.
Thank you, sir. Thank you, everyone, for sharing your valuable insights for the contribution. For your contribution, the platform has been a great as the all-round contribution from the policymakers to the policy implementers to the OEMs. They were there and they have given their inputs likely, which will be helpful in the coming days when the smart meter is going to expand a lot. So with this, I would like to conclude this session, and I would request to present a token of memento to our esteemed speakers. Shri Tejas Parmar, MD, MGVCL. Thank you, sir. Thank you for your valuable inputs in the session. Shri Rohit Pareek, Chief Product Officer, Impresa.ai. Shri Phil Wisher, Vice and Alliance. Shri Ganesh Kashyap, CEO, Landes and Gear. Shri R.J. Wala, Chief Engineer Projects, PGVCL. Shri Shubhadeep Rai Chaudhary, Additional General Manager, TPDDL. Shri Chandra Goel, Principal Engineer, Texas Instrumentation. Shri Partha Sarthi Krishnan, Executive Vice President, Hardware and Firmware, Science Connaught, India. Shri Gopinath Mishra, Product Manager, Digital Solutions, Kimball. Shri Lalit Rao, President, Applentone. Shri Amit Bansal, DGM Metering, NPCL. Shri Rathin Swami, KS, co-founder, Enthu Technology. I would now request all the speakers for a group photograph. Thank you.